various recognition, including the Young Researcher Award, Best Paper Award, Top Performing Mentor Award from NPTEL, and multiple mentor awards from the Ministry of Education and the other leading education institutions for her outstanding contributions to teaching, research, and mentoring. A passionate educator and lifelong learner, she has successfully completed numerous professional certifications from Cisco Network Academy, NPTEL, ICT Academy, and other reputed organizations in cybersecurity, data science, Python, research methodology, and digital teachers. Her commitment to continuous learning and interdisciplinary research has made her a highly respectable academic leader. With her rich academic experience, research excellence, and expertise in artificial intelligence and healthcare analytics, Dr. V. Sobna is exceptionally well qualified to deliver today's session on deep learning approach in medical diagnosis. On behalf of Vlbjcas College of Arts and Science and the organizing committee, I extend a warm and a cordial welcome to Dr. V. Sobna ma'am. We are truly honored to you have with us, eagerly looking forward to your valuable insights. Dear students and professors, please join me in extending a warm round of applause as we welcome Dr. Sobna ma'am. Thank you.
Thank you, sir, for the warm welcome. Now, it is my honor to invite Dr. V. Shobana ma'am, Professor and Head, Department of AI and DS, NGP Arts and Sciences College, to deliver today's technical session.
இந்த லைட்ஸ் மட்டும் ஆஃப் லைட்ஸ் ஆஃப் ஸ்லைட் ஸ்லைட் ஷோ இந்த சேர்ஸ் எல்லாம் டிஸ்டர்பன்ஸ் இருக்காங்க. சேர்ஸ் எல்லாம் மூவ் பண்ணிக்கலாமா இல்லை அது செகண்ட் ஸ்லைட் போயிடுங்க. செகண்ட்ஸ் செகண்ட் செகண்ட் தானே.
So very good afternoon to all. So thank you for introducing me, sir. And I take this opportunity to thank the organizers for inviting me in joining this 6 days Atal LBT program. And I hope this will be a tough session for the next 1 hour or 1.5 hours. So since post lunch, so we cannot able to sit for a long time. So I tried my maximum to put you active in an active mode. So our topic today is about the deep learning for medical diagnosis. So in our day-to-day life, so one way or other we are facing so many medical complications or something like that. So for each and everything we are approaching a doctor and the doctor has to prescribe the appropriate treatment so that we can come out of that disease. So in this aspect, so as a computer science researcher or as a researcher in general, so how we can contribute to the healthcare society, say for example, so how we can make use of this deep learning techniques or machine learning or artificial intelligence, so which will help the doctors or clinicians to make a better decision in identifying the disease and recommending for better solutions. So many researchers has proposed so many solutions, and we are going to have a deep overview of how this deep learning or artificial intelligence or machine learning is going to help the healthcare industry to have a better treatment for all the people. So that is the thing we are going to discuss. And this is the session plan. So we are starting with artificial intelligence, that is what is artificial intelligence, machine learning and deep learning is. So then we will be moving to the fundamentals of deep learning, followed by medical imaging and healthcare data. So then deep learning applications for medical diagnosis. So then we can have some discussions on the different cases in healthcare industry. So what are the challenges and ethical issues we will face? So then the last one, it is about the future trends, how it is going to be, where it is going to stop or where we are going to proceed. To start with, so here, if it is deep learning, so then it is an area under artificial intelligence, it is a branch under machine learning. So all these things are interrelated with each other. So as we know already, we know what is an artificial intelligence is. So all the things are related to each other. So we can connect one term with the other. So here, my question is, can artificial intelligence diagnose a disease earlier than an experienced doctor? So here, we might have a question like, we have experienced doctors of 20 years or 25 years or maybe 30 years. So can an AI able to predict a disease than those experienced person? So I want answer from your side. Can an AI beat the doctor, those who have 30 years of experience, can it able to predict it correctly without any human intervention? Obviously it is no, right? So we should provide some sort of input to the artificial intelligence, that is the doctors can combine with the artificial intelligence or the machines. So with the help of it, so we can able to predict the disease. So not completely AI can able to predict, it can make mistakes. So here my point is, so it is not like 100% fully it can able to predict the disease of its own. So we need some experiential inputs from the doctors so that we can able to predict the disease correctly. So I have a video, so we can come to that later. So here I want to introduce the three terms. So probably most of you will be knowing. So to start with artificial intelligence, it is a broad field of making machines to do their tasks. So we all know artificial intelligence is nothing but it is making a machine to do our tasks. So nowadays we are exposed to so many artificial intelligence tools which can make our work easier. So next one, it is deep learning. So deep learning, it is nothing but it is the most advanced approach, so which uses layered neural networks. So it is a branch of neural networks, so where we can able to apply the deep learning concepts. So here it is AI, it is the big umbrella. So under that I can able to bring in my machine learning as well as my deep learning. So that picture also it says like under artificial intelligence, I have so many sub branches. So in that one part it is my machine learning, and the next one it is the deep learning. So here we are going to focus much on the deep learning approaches which is applied with our artificial intelligence. So here our topic is related with the healthcare and why we need artificial intelligence in healthcare. So what it can able to do. So the first point is we have patients increasing in number. So even though we have so many healthcare professionals, so they cannot able to handle all the cases easily. So if the patient number is increasing, so we cannot able to handle the things easily. So in that case, we seek the support of a machine. So in that case, the very first point is it is increasing of patient population. So second one, growing shortage of skilled healthcare professionals. We were in lack of very skilled care professionals, so we can able to reduce the number by introducing machines for certain tasks. So that is one need. So the third one, it is the rising healthcare cost. So instead of investing with so many things, we can make ease of certain things. So that is one reason. So why we need artificial intelligence in healthcare. So then increasing number of chronic diseases. So then the need for faster and more accurate diagnosis. So if you are depending on machines, so then the humans, so we can make our task easier. So if a human can able to do the task in 1 hour, a machine can do it in 5 or 10 minutes. So that is one reason where we need artificial intelligence. So then large volumes of medical images, so that requires machine experts suggestions. So for all these reasons, so yeah, we were looking for artificial intelligence in healthcare. So here it is like what is an artificial intelligence is, what is machine learning, and what is deep learning is. So artificial intelligence, as we have discussed already, it is a broader field. So under that, I can able to bring in my machine learning and deep learning. So where all these things are applied is, so artificial intelligence, it is like a chatbot which answers for the questions. So hope most of us is using the AI chatbots, right? So nowadays we have so many chatbots for things. So artificial intelligence can be used like that. So here machine learning is nothing but, so it can able to learn from the existing patterns. So that is what machine learning is. So say for example, I can able to detect and spam mails out of all the mails what I am receiving. So the third one, it is deep learning, which is nothing but compared to machine learning, it can able to recognize complex patterns. So the patterns may be simple and the complex, maybe the patterns may be complex. So deep learning is applied where the patterns are becoming complex. So say for example, if you are looking at the medical images, so all the images will be one way or other it is complex. Say for example, if you are taking a chest x-ray, or if we are taking the MRI of our brain, or the whatever the thing, different images. Certain things we cannot able to see. We cannot able to say what is happening in the picture. So those complex patterns I can able to analyze with the help of the deep learning methods. So say for example, this is an thing. So how it works in real time. So say for example, we are going to teach a child how to identify a fruit. So if the child is 1 or 2 years, so we want to make the child to identify what fruit it is. So how this artificial intelligence will be applied is, artificial intelligence generally is a rule-based one. So what it can do is, so it will define a set of rules like if it is red and round, so we can call that as an apple. So then if it is yellow and long, we can call it as an banana. So likewise, we will be defining rules in artificial intelligence to identify a fruit. So the same way, if you are using machine learning, instead of defining the rules, what we can do is, we can show a similar patterns of images. Say for example, giving the images of apple or giving the images of banana or something like that. we will be showing the pictures of those fruits. So that is what will be happening in our machine learning. So by showing the pictures, instead of defining rules, by showing the picture, the child can able to identify what type of fruit it is. So this will happen in machine learning. So if we are going to deep learning, so the same pictures will be shown, but the pictures will be shown from different angles. So it is not like showing the picture in one direction. So we will be showing the pictures in different directions, that is different angles, so under different lighting conditions. So if you are seeing a picture in sunlight, it will look in one color. If we are looking at a dark room, we can able to see it in a different color. So likewise, so we will be showing that picture under varying lighting conditions. So then at different stages of ripeness. Say for example, if the apple is fresh, the color will be bright red. So if it ripens or if the day by day passes, so the color will change automatically. So all these things will happen in a deep learning thing. So instead of showing a picture, so we are making a full complete set of like how it looks at different angles. So then how it looks in different lighting conditions. So then how it looks in the different stages. So likewise, all the medical images will be handled like this. So if we are applying the deep learning techniques, all the medical images will be done like this. Instead of giving the image and taking out of the prediction or classification, so we will be analyzing the image in different aspects like this. So this is what the deep learning techniques is. So if we are doing it like this, so once in over a time, so we will not miss any of the things. We will not miss any of the things. If you are showing a single picture, so you can able to see the apple in red fresh color. So if you are seeing the same apple in different stages, so I can able to identify the apple in different stages. So even if it is in ripened stage or if it is in fresh stage, I can able to identify it correctly. So that is the advantage of deep learning here. So that is why deep learning is preferred in medical diagnosis also. So why deep learning is preferred in medical diagnosis is, so it will detect the diseases at an earlier stages, so then it will reduce the abnormalities. So as I have discussed already, so if you are showing the apple in different lighting conditions or if you are showing the apple in different stages, so it can able to reduce the abnormalities. It cannot miss any of the picture of an apple. So then analyze thousands of images rapidly. So then improve the diagnostic consistency. So then it will support the clinicians in making a better decision. So that is why deep learning is preferred here. So that is what given here in this picture also. So it will detect the diseases at the earlier stage, starting up to supporting the clinicians in making a better evidence. So I want to answer for this question. So since we have seen deep learning is nothing but it will detect with high accuracy, right? So we have come to a conclusion like if deep learning can detect the diseases with high accuracy, again the question is can it will replace doctors in future? The same question what I have asked in the first slide. It is no. It will support the doctors in making decisions. So that is the answer. So the answer is no. So why? It is designed to support the healthcare professionals, not to replace the healthcare professionals. It is made in such a way that it will replace, it will assist the healthcare professionals in making better decisions. So here the basic behind this deep learning is nothing but the neurons. So everyone will be aware of like our human brain is made up of neurons. So we have millions and billions of neurons. So here this biological process has been artificialized to make it as an artificial neural networks. We all know this deep learning is the basis of the deep learning works under the basis of neural networks. So it is like our human brain. So we are making our brain to act on behalf of us. So we are replicating the human brain with the help of this artificial neural networks. So our human brain is made up of so many neurons. So that neurons has been artificialized, and here it is called as an artificial neural networks. So the entire biological process, it has been made as an artificial neural networks. So that is the technique behind my deep learning. So artificial neurons are very simpler than the biological neurons. So it is combined into multiple interconnected layers. So then it is capable of learning high complex patterns from the data. So the different things that has been related with that. So here the biological neuron, it is called as an dendrites, which will receive signals from other neurons. So whereas here this dendrites, which is present in biological neuron, it is called as an inputs. So which will take our input images. So that is the first step. So second step, cell body here, it is in biological neuron. So there it is called as an weights and biases. Nothing but to which feature of the image has to be given importance. So that will be calculated with the help of weights and biases. So the third one, so here it is called as an axon, which will take the processed signal throughout our body. So there it is called as an summation after learning the, after reading the input image, after taking the, what you call as the important features. So it will take you to the through the different steps. So next one, neuron firing, here it is. So here it is called as an activation function. So in our artificial networks, it is called as an activation function, which will determines the neuron has been activated or not, that particular neuron. So then here it is called as an synapse. So there it is called as an output. So taken the input. So if you are looking at a picture, so we can able to say what picture it is, what type it is, or if you are hearing something, we can able to say what sound or whose voice it is, something like that. We can, our brain can able to recognize what it is actually. Our brain is trained in such a way that, so you can able to recognize an image or picture or sound or a video, something like that. The same way, we are making the computer to work in the same way like how our human brain works or functions. So that is why this artificial neural networks has been introduced, and the different terms that has been associated with the artificial neural networks has been discussed here. So this is what the things, the basic things which is needed for an deep learning. So this is the structure of your biological neuron. So all the information has been traveling through the different parts of our body. So here, the same image structure, it has been given. So what we have discussed in the previous slide, input. So then the important features will be read. So then followed by everything will be taken to an summation function. So later it will be given to an activation function. At last we can able to say what is the output is. So this is biological one, and that is artificial neuron. So here we have traditional neural networks. I think you all aware of what is a neural network is, and we have certain traditional neural networks algorithms. So why we want to go for an advanced one, since we have a traditional neural networks algorithms. So why I want to go for some certain advanced neural networks concepts. So the answer is, so say for example, if you are taking an image of an X-ray, so we all know the pictures are recognized with the help of pixels, that is the picture elements. So say for example, if the image is of this much amount of pixels, so it has to, what your traditional neural network algorithm will do is, it cannot able to process such a long pixel images. So in that case, we want to move for the advanced concepts of neural networks, that is ANN followed by deep learning. So what are all the challenges that we face if we use this artificial neural networks for images? So you have to use a number of, that is millions of input neurons. Input neurons is nothing but all the input images. So what I have discussed in the previous slide, so here we have this much amount of pixels. All those pixels will be treated as neurons. So we need much of neurons to process here. That is one thing. So the cost is extremely high, and the computational power needed is also high. So then we need large memory requirements to process such image. So then increased risk of overfitting. So sometimes it will not give you the correct results. We may result in overfitting. So then spatial relationships between the neighboring pixels will be sometime lost. So all the picture elements, it has to be connected properly to get a final image. So that will be lost here. So to overcome all these things, a specialized deep learning architecture, which is called as an convolutional neural networks, that is CNNs, which is used to automatically learn visual features from an images. So in most of the healthcare data, all the data that we will process is in the form of images. So here it will focus on, so these are the different parts of our pictures. So these are the different things. So if it is an image, we want to go for edges. So what is the shape of an image? So then what are the textures? Textures is nothing but, so whether it is dotted or something like that, they will be using different textures in our pictures. So textures. So then what organ we are going to scan, or we can take it as an example. We will be taking brain, we will be taking lung, we will be taking breast sometimes for cancers. So we will be what type of organs we are focusing on. So then the lessons and the tumors. So all these things has to be focused. So since it is healthcare data and we are not going to deal with any apple or orange, something like that, we are going to deal with the different organs of our body. So each image will have its own characteristics. So if it is brain, so it will have its own shape, it will have its own texture, it will have its own shape. If it is a lung image, again it will have its own shape, own texture, own characteristics. So to concentrate on all these different types of images, so we are introducing that is a specialized deep learning architecture, which is used to automatically learn the visual features from the images. So here where it is CNN is introduced. So why this CNN algorithm is preferred over this artificial neural networks is, so it is excellent. According to the researches that has been done, it is excellent for image recognition performance. It has shown good results there. So fewer parameters than the fully connected networks. Instead of concentrating on so many neurons, it will concentrate only on fewer parameters. So then it preserves spatial information. Spatial information is nothing but, so the different dimensions of the images. So then it is highly effective for medical imaging data sets. So past researches has proved all these things. So that is why we were preferring CNN over other algorithms. So these are the different stages of CNN.
So can you zoom in the picture?
Control scroll. Okay. So here, this is the image of an lungs. This one part of our body, right? So this is the image of an lung. So the input will be the lung image. Okay, so what I want to do is whether my lung is infected or not. I want to diagnose whether it is in normal stage or it is affected with pneumonia or some other type of disease. I want to identify. So how this image passes through different stages. So the first one, it is the input image. So it will pass through one layer called the convolution layer. I'll explain what is that one layer in the next slide. Convolution layer. So then it will go for the activation layer. So where again I will be using an activation function value. So then followed by the fourth one, it is the pooling layer. So So the fifth one again, it is one convolution layer, pooling layer. So then followed by fully connected images. So at last, what I want to get is, so what is the condition of my lung? Okay, what is the condition of my lung? So it will pass through different layers. At last, I'll be getting an input like whether my lung is normal or my lung is affected with COVID-19 or if it is affected with TB or pneumonia. So this is what I want to do with that image. The doctor will have an X-ray of my chest. So after passing through all these different layers, all the tests will be done by the machine. After passing through the different uh, layers, so what I can able to conclude is what type of lung it is, whether it is a normal one or it is affected with some sort of disease. So this is the process I want to do it with CNN. So the same for if you are taking an MRI of your brain, or if you are taking your chest X-rays, or if you are taking your uterus or something like that, you will be taking an image of yourself and you want to say whether it is a normal one or it is affected with some sort of disease. So this task, it has to be done by a machine. So in the previous cases, if it is not an AI assisted one, if a clinician or if a doctor has to analyze, so what we will do is we will visit an lab technician to have our X-ray of our own, and once the X-ray or the MRI or CT is done, we will be taking the result and we will be visiting the doctor again to have a consultation like whether our organ is normal or not. So this process, it takes time, and the doctors also, they will need some time to recognize what it is actually, whether it is okay or not. So to make this process easier, what we are doing is, so we are making it everything computerized. So to make it computerized, so your computer has to be trained in such a way that it has to diagnose your thing correctly. It has to diagnose whether it is, it should not say if the lung is normal, it should not say it is affected with COVID-19. If you are affected with COVID-19, it should not say it is normal. So the process has to be done clearly. So that is why we are proposing so many types of techniques, and at last we are landing in this deep learning technique. So this is the task we want to do with the help of a computer. So to talk technically, so these layers we have discussed in the previous one. So what your input layer will do is, it will receive the original image. Say for example, I have shown the X-ray, or you can take any form of image here. You can go for X-ray or MRI or CT scan, whatever it may be. You can take that as an input. So obviously what we will be doing in our, if we have visited a doctor with those kind of images, so what a doctor will do is, so they will be opening a medical image on a computer screen. So if the doctor is doing, so this is the process of a doctor, so this is the process of a machine. So the second layer, it is the convolutional layer. So what your computer will do is, it will scan the images using small filters. It will scan the images using small filters. It will look for important features such as edges, shapes. So that is what we have discussed. So it will look for important features. So what your doctor will do? So with the help of, the doctor has opened the image in a computer screen. So the next process is, he will also look for the different parts of an X-ray for any, if there is any type of abnormalities is present. So that will be done in the convolutional layer of your deep learning. So the next, the third step is, it is your activation layer. So here ReLute is a function which is used on behalf of this activation layer. So what this will do is, it will remove the unnecessary negative values from the images. So that is what your computer will do. What your doctor will do is, he will not look into all the features of your image. He will look for only the important observations, so while ignoring the normal details. So he will look only for the thing. So that is the third one. So the next, the fourth one is, what your computer will do is, it will convert the extracted features. That is what important features it has been extracted. So that it will take only the extracted features. So likewise, here also, what your doctor will do is, so he will look for only the parts of the images that has been affected. So next, the fifth one is, it is the fully connected layers. So what it will do, it will combine all the features that has been extracted. So here, your doctor will combine all the results. Say for example, if he has suggested for any other results, so that results along with the images what he has screened, all those things will be combined here. So here, after combining all the things, what I can able to see in the result is, I can able to calculate the probability of each type of disease. What the disease is, it will come to a conclusion. So like what I have shown in that picture, whether it is in pneumonia or COVID or it is in normal lung, so I can able to come to a conclusion with the extracted features. So here the doctor will also say the same thing by looking at all the things. So he can able to say what actually your lung or your images, whether you have been affected with anything or it is normal. So this is the different process under my artificial neural networks. So conventional neural networks. So if we are working on any research papers or projects, so we want to go through the different layers. By taking one image, so we want to take that image through different layers. At last, I can able to come with a conclusion. So this is the summary of the thing. So what it can do is, it will look at the image, it will identify the important features, so then it will remove the unnecessary information, so then it will combine, and last it will come with a conclusion. So this is what CNN will do. So next, so even though CNN is good for in most of the cases, so as far as the growing diseases and the growing number of populations, so there are some additions or updations that has been made with the CNN, and we are developing an advanced CNN architecture which will improve the accuracy, speed and efficiency. So even though CNN is performing good, so as a researcher or as a doctor, so we will be adding some things with our existing CNN algorithms, so which will come out as an advanced CNN. So these are the different architectures which is used under, that is the different techniques used under CNN. So we have different architectures here, that is AlexNet, VGGNet, RSNet, so then DenseNet followed by EfficientNet. So we can go for, if you are doing any sort of image analysis or something like that, so we can go for the different architectures. Under CNN, we can prefer these different architectures. So this one, if I am preferring AlexNet, so what type of images I can able to apply? For what images I can able to apply this AlexNet? So for X-ray image classification, I can go for that architecture. So if it is breast cancer or MRI analysis images, so then I can choose that architecture. So for each type of images, so we have different architectures for architectures under CNN, so which will give you the better results. So why all these models, again it is so popular, is it will improve the diagnostic accuracy, so it will learn complex disease patterns, so then it will reduce the training errors, so then it will work with large medical data sets, and the last one, many are available on predefined models for transfer learning. All these models are trained previously, so we can make use of the models to have our own diagnosis. So all these CNN architectures, it is used for image classification. So what if a doctor needs to know the exact location or the boundary of tumor rather than just where it exists? So going deep into the image, a doctor wants to know which part of the lung or which part of the brain has been affected. So he or she wants to know very particular about in which location or which part of the brain or which part of the lung has been affected. So in that case, we have been introduced with an architecture, different architecture called UNIT. Along with the other architectures what we have discussed in our previous slides, we have one more architecture called UNIT, which will specifically designed for locating the exact location and the boundary of a tumor. Say for example, if I am looking for a tumor, so then I should identify, or I should say, or my computer should say, in which part of the image the tumor is present, the exact location. So if we want to go for it, so then in that case, we can go for an architecture called unit, which will give the exact location of where the tumor is, and it is specifically designed for image segmentation. So this image, it is used for object detection. It is an output of an your unit architecture. So where it will show you the affected part of the lung or brain or whatever it may be. So it can able to highlight the parts. It can able to shape. I mean, we can look at the shapes here. It is not normal. It is like, it is not square or it is not round. We can able to see the computer has diagnosed the exact location where it has been affected. So that is the advantage, or that is the usefulness of our unit architecture. So this is also, if we are taking different medical images, so I can able to say, that is the unit architecture can able to say which part of the image has been affected. It is not like in a normal round or square shape as I have said earlier. So it is like the different parts of the images that has been affected. It can able to point out the exact location. So here unit is nothing but is used for medical image segmentation. So we cannot say, if we are taking a full scan of our brain, we cannot say our brain is fully affected. So it is maybe a part of the brain or a part of the lung will be affected. So we want to segment that part alone from the entire image. So that is what image segmentation is. And here this unit is very much needed for this image segmentation, and it also comes under this deep learning architecture. So what our CNNs can able to do is, it can able to classify an image. Whereas our unit is, we can able to say which part of the image has been affected. So that is what the thing is. It can able to say the exact location, shape and boundary where it has been affected. So their CNNs, it can able to classify your image. So here your unit is, it will identify the exact region of the disease. So it will highlight the size and shape of my tumors or lesions. So then it will assist the doctors in treatment planning. So if it can able to diagnose which part, so the doctor can able to suggest you within better treatment plan. So then it will provide pixel level prediction for accurate segmentation. So where pixel level is not possible in our artificial neural networks, so here this pixel level segmentation is possible with our unit architecture. So that is what the growth of the neural network architectures from artificial neural networks to CNNs to this unit architecture. So the different components of our unit architecture. So it takes, as the name says, it takes the shape of U. So the input image, it will be passed through an encoder. So then it will have a bottleneck, that is at the bottom. So then it will have a decoder. So then followed by the output. So as how we have discussed in our conventional neural networks. So here also it will pass through different stages. We will be taking an image. We will be extracting the important features. So then it will capture the most important and the sample features of the image. So later it will restore the image size, and followed by it will provide an pixel level segmentation. It will take a whole image and it will say you at last. So there in CNNs, it can able to classify like whether my lung is normal or it is affected with some disease. That all it can, CNN can able to say. So here this unit, it can able to identify which part of the image has been affected. So these are the different stages of my unit architecture. So as I have told you, this is the shape of my architecture. So the different phases, it will take in U. Again a lung image has been taken. So the lung image, So it will pass through the encoder, so then decoder and bottleneck, and at last I can able to say which part of the image has been, which part of the lung has been affected. So under which scenarios this unit architecture has been applied is, so the first one, it is for brain tumor segmentation, so then lung nodule detection, so the liver and kidney segmentations, so then retinal blood vessel, so then organ boundary direction. So in almost all the cases our unit architecture has been applied. So what are the different models I can able to prefer for which type of data? So say for example, if it is a breast cancer, so what type of medical image I'll be using is, I'll be taking a mammogram of my image. So if it is mammogram, so what algorithm I can able to prefer? What algorithm or architecture I can prefer for better results? So if it is brain tumor, so then the type of image that we will be using is MRI. So here the deep learning model I can apply is, I can go for unit as well as ResNet. ResNet is one form of unit architecture. So then for the different diseases like pneumonia, diabetic, skin cancer, so we have so many different types of images. Not all images, not all models will be applied for all images. For each type of image, so we have to prefer the corresponding models under deep learning. So this slide explains that. So how your deep learning model, that is your unit, works is, it will take an input scan, it will pre-process our data, that is extracting the, removing the unwanted features. So then we will be applying the deep neural model that has been what we want to use for which type of image. So then at last we can come up with an extraction and output. So CNN versus unit roles is, so as I have told you already, whatever CNN will do, it will say what type of disease it is, whether your image has been affected with what type of disease. So whereas my unit model, it can able to come out with which region or which portion of the image has been affected. So that is what the difference between the CNN and unit roles. So what we can able to conclude here is, as I have told you already, CNN, it is used for classification of your image, whereas unit is used for extracting the portion of the image, which portion of the image has been affected with what type of disease. So that is what the difference between CNN and unit. Both the things are applied for medical images. So if I want only the classification of images, so then I can go for CNN. If I want to get deeper into the image and I want to say what actually happens or which portion of my image has been affected, so then I have to choose models under unit. So here again it is an case study of my brain tumor reduction. So how it is happening in using unit. Can you please zoom? So here, if it is brain tumor, so obviously the image what we will be taking is, we will be taking a brain MRI. So the brain MRI will be the input image which will be given to our unit or ResNet, what type of model we have chosen. So from this, what we will be doing as in pre-processing is, so we will be removing the noise removals, that is the extra features or image normalization. So if I want to increase the contrast of my image, so that all will be done in pre-processing steps. So the image will be kept ready for analysis. So then it will be taken to your CNET or unit model what you have chosen here. So here, as I have told you already, we have two different things. One is the encoder and the next one it is the decoder. So the encoder will take your entire image it will minimize the size of your image so that I can able to identify which region or which part of the image has been affected. So then later on it will be expanded. It will be expanded so that I can able to see and better visual of my image. So here in the feature extraction and segmentation phase, so I have taken an original image. So what I can able to identify after this application of this model is, I can able to say in which portion of the image has been affected, in which part of the brain a tumor has been detected. So it will detect the abnormal tissue, so then it will identify the tumor location, so then it will measure the boundary of the tumor. So this is what will be happening in the fourth phase. So in the last part is I want to say the output, whether my brain is normal or it has been affected with any type of tumors. So that also my algorithm can able to say. If you are using CNNs, so your CNN will not take into consideration this one. So it can able to say what type of tumor it is. So if you are applying unit along with CNN, what it can able to say is, it can take your image, it can able to say which portion of the image has been, which part of the brain has been affected. So then followed by the different classifications. So like I don't have tumor, or I have these different types of tumors. So if you are looking at a computer, so if you are feeding your computer with this data, okay, what a doctor can able to see is, they can able to see the output of this one. They can able to see the output of this one, that is the image has been segmented. So what is happening between these two is what I have explained there. Application of unit and resonate. So this will make the task of the physician easier, so that if they are giving in an input image, so they can able to come out with a conclusion like what has happened or which part has been affected. So here this is very, very sensitive information, or your machine should not make any wrong predictions or something like that. So before deploying all these things in any type of healthcare hospitals or something like that, it has to be tested with hundreds and thousands of images to have a better accuracy. So later on, if we are okay with the models or the architectures, so then only we can able to proceed with the live scans and images. So this is another case study of your lung. So again the same process. At last I want to say what my lung is, whether my lung is normal or it has been affected with any sort of disease. The same process again. An input image will be taken, and here also we can able to see. So I have taken an input image. So then here my computer will say what part of the lung has been affected and what type of infection or affection it is. So it can able to say. So having learned the process, I have given only the basic steps. I have not into the deep of how that unit is working or how it is making classifications. So it will take another a few hours to have an whole implementation. So here what are the, even though if we are looking at the previous slides, it looks very simple. If I am giving an image, I can able to get a prediction out of it. But this requires a lot of tasks, like we face certain challenges and ethical issues here. So what are the challenges I will be facing here is limited medical data. So since it is a patient data, so we cannot easily get the data from the healthcare professionals. So we cannot work on with the dummy data, what is available in the websites or something like that. So if we are getting the live data, so then we can make our models more accurate and more predictable. So that is one challenge we will be facing. So the next one, it is data privacy. So since this is patient information, so we should deal it with care. So third one, it is the model bias. So sometimes, as I have told you already, so all the times it will not give you 100% accurate results. So we have to be very careful in giving the results to a live patient's data. So then lack of explainability. Lack of explainability as in that. So what I have told you. So we cannot explain each and every part, what is happening, how it is identifying. A patient will question like whether this data, whether this analysis is correct or not, whether this prediction is correct or not. So we doesn't know, we will not, obviously we will not, trust in machine than a doctor. So in that case, so lack of explainability is also a challenge. So then if you are applying all these deep learning models, then the computational cost also will be higher. So these are the challenges. And what are the ethical issues? So since it is an healthcare data, so we will be facing certain ethical issues also, like what I have discussed as challenges. The very first one, it is the privacy of the patient. So next one, it is the fairness. So transparency, accountability, human oversight. So just like that, we cannot trust a machine. We cannot say the what machine has predicted is correct. So a patient will not easily accept like a machine saying like I have a tumor. A patient will not trust that. So we will face certain ethical issues like this also. So this needs a lot of care and attention. So what are the different future trends in, that is if I am proceeding with the deep learning approaches or models for my research or for my projects. So I have different future trends. So here one is the vision transformers. So in continuation with the ResNet or the unit models. So I can proceed with certain trends in deep learning methods where researches are going on. The first one, it is the vision transformer, so which will use attention mechanisms to analyze our entire medical data. Along with the unit, we have certain other things also. I have federated learning. Federated learning is nothing but integration of AI into the deep learning models. So then digital twins. So creating a virtual model of, you can able to see here. So I will not be creating the model each and every time. I'll be creating a digital twin of my model. So where it can able to replicate itself and it can able to work for all types of data. So then next one, it is multimodal AI. So this is one type of technique where I can use it with all the medical data sets. So generative AI. So then AI assisted robotic surgery. So I think we were witnessing this in some of the hospitals where a robot is making the surgery. So these are the certain areas we can able to concentrate on if we are working with the medical data sets. So what we can able to conclude here is, so we cannot say deep learning is changing the healthcare industry. That is, it is transforming our medical diagnosis through and faster and more accurate predictions and disease detections. So CNN will classify your medical images. That is what we have seen. So and our unit architecture. So it will identify the exact shape and size of the image, and it can able to find out the abnormalities. So here explainable AI, which we have not into it, so it will improve the transparency and the clinical decisions better. Explainable AI, again it is a branch of artificial intelligence where it will say what is happening inside a model. That is one field under artificial intelligence. So then emerging technologies like the vision transformers, what we have discussed in our future trends, so are shaping the future of our healthcare. So we can choose any one of the future out of it. So here artificial intelligence is an intelligent agent, so it is not the replacement of doctors. So what I have said in the first slide, it is not the replacement of doctors. So human expertise along with the artificial intelligence, it will improve the accuracy or the decisions of doctors in a better way. Not AI alone, it is with the assistance of the human intervention. So the future of healthcare is the combination. It is not between human and artificial intelligence. That is human versus AI. It is the combination of human plus AI which will improve the diagnostic as well as it will improve the healthcare industry and it will take it in a better way. So I think I have a video here. So I think if possible we can play the video. So it is a short video about how this artificial intelligence or what is the techniques that we have discussed so far is assisting in healthcare industry.
You cannot have the sound. Okay. Sound இருந்துச்சுன்னா it will be better. இல்லை வால்யூம் ப்ளே பண்ண முடியாது. Or else if it takes time, you just leave it, no issues. Okay.
So meanwhile, if you have any questions or you can ask.
Ma'am, it is okay. If you don't have, it is okay. It is okay. I'll share the video. You can share it with them. No issue. It's okay. It's okay. If you have any questions, you can ask or else we can wind up. Is it okay?
Thank you very much, Shobna ma'am, for your excellent and enlightening presentation.
AI models trained mostly on light-skinned patients